So here's a basic explanation of how heat and air conditioning work from a perspective of the heater box, as I call it, or sometimes they'll call it the heater unit or HVAC unit assembly. So this is basically, you can see your dash vents, right? But normally you'd have this whole dashboard enclosing all this ductwork in this box. And so just kind of to give you an idea, we've basically just kind of hung some of the controls, and I want to talk about each control and how it works. So first thing, let's look at the blower speed. So effectively all you're doing here is you're just changing the speed of the blower motor, and there's different designs, but this is an older style. Off is obviously off. Low is basically going to send current, and I'm going to summarize, and for the point of understanding here, it's going to basically send current to this resistor, which is right here. Can't see it very well, but each one of those wires come from the switch, and from that resistor, some amount of current is going to go right to this two-wire connector, and this right here is the blower motor. So this would be kind of like the glove box. So if you were to, open up the glove compartment, you may not really see this, but if you were to look under the glove compartment, you would probably see this type of a assembly, and this connector right here is your blower motor connector. So if you have a blower motor in op, this is most likely where you're going to do a lot of your testing. We should have 12 volts and ground here. Now, more about this blower resistor. This is the blower resistor connector. The blower resistor is inside, and I'll show you what a removed one looks like. But basically, each one of those wires is, in this older model, going to get a signal from this switch. And so you would basically on low get current leaving the switch, summarizing, and it would go through the resistor. And depending on what speed it is, low for example, it would have to go through 3 separate resistors to then go to the motor. So by the time it gets to the motor, there's going to be a lot less voltage left because the 3 resistors are going to consume a lot of voltage, and the amperage is going to be pretty low, so this motor is going to turn slowly. If you turn it up to speed 2, it's going to go only, it's basically going to bypass 1 resistor, and that's going to mean the overall resistors would be like going through 2 resistors rather than 3 resistors, and so you're going to have a little bit higher voltage making it to the motor at a little bit of a higher current, and that's going to make the motor turn a little faster. Then if you go to the next speed, that's going to bypass 2 of the resistors and only make the current go through one resistor, which gives you even higher blower speed, and even, basically because you're going to have a higher voltage. Not quite 12 though, because this blower motor is still sharing that voltage with 1 resistor. So maybe it's going to have 9 or 10 volts, and it's going to be at a higher amperage. Now when you go to full-on high, that's going to bypass the resistors entirely, and we're going to just get direct 12 volts. Now this is really a summary of how the system works. Every system's a little different. Sometimes there's a blower relay built into the resistor and it triggers the relay, but essentially you should have your full source voltage here, whether it's one design or slightly different or whatever. Now on the newer systems, the blower resistor has been replaced with a blower transistor, and basically all the transistor's doing, it's giving a duty cycle, an on-off time to the blower motor. And so really this is an overall, not exactly how the blower motor operates, but this should give you kind of an idea. So the car comes in and that blower motor's not working, you may just want to come down here and see if it's getting 12 volts in ground. And that would be for the non-duty cycle style. Additionally, some people, kind of know about a little bit of a trick. You can sometimes jar the motor and it'll start to work. And so let's say we got a slightly different issue. You are operating the switch, and let's say low works, speed 2 works, speed 3 does not work, and full speed 4 works. More than likely, your issue is going to be in the blower resistor itself, but you would, really the right way to diagnose it would be to go in the wiring diagram and test the voltage from the switch to the resistor. You could test the low wire, the speed 2 wire, the speed 3 wire, and the 4 wire, and you'd verify that it's getting signal from each one of them. So a lot of that's really specific wiring diagram, tracing, and whatnot. But if you think about it, if 3 speeds work and 1 doesn't work, it's certainly not going to be the motor, because the motor uses the exact same wiring whether it's in speed 1, 2, 3, or 4. The resistor itself, sometimes what happens is one of the resistors inside go bad, and it may only use, depending on the design, it may only use that one resistor in that particular speed. Now on this one, those resistors are in parallel or in series, so it's a little bit different, but this is kind of the general overall view of the system. And so from there, we understand the blower speed. Let's just go in the left to right motion. This is the temperature control, and so the way that temperature control works on this one is as I move this, check it out, I'm literally just moving a cable. Very, very simple. It's good to start with this simple one so that you understand that cable is moving this door. This is the hinge to a door. And this door is basically controlling if the air comes in and goes through the heater core or bypasses the heater core. Now in this model, and every model is slightly different, all of the air goes through the evaporator core. But on some models, it'll either go through the heater core or through the evaporator core. So if we want cold, like so, the door is going to block off the heater core, and the heater core is going to remain hot, but the air is not going to go past the heater core, so the air will be cool. And then if we actually turn on the AC is going to send a signal and actually activate our AC compressor, which we have a simulated one here. It's going to turn on our fans, and those fans are going to cool the condenser. And then as the refrigerant circulates, it's going to drastically cool the evaporator core. Now on this one, just looking, it's a little bit tough to see, but this line comes up from the condenser through the receiver dryer, and it goes to this point here, and this is actually our thermal expansion valve. And from the thermal expansion valve, if we were to pull this boot off, you can see these lines go inside the box. So our evaporator core is right here. Obviously that means if we need to change an evaporator core, we got a lot of work to do. This whole box needs to be split. To even get to this point, you're talking about, pulling the dash, dropping the steering column down, probably pulling the seats, most definitely pulling the center console. So you're hours and hours and hours of labor to even being able to touch this evaporator. Now this is a little bit older style, so the TXV, as we call it for the thermal expansion valve, is mounted on the box. A lot of the newer style, the TXV is out here, and it actually protrudes through the firewall, so you'll pop the hood, you'll see a TXV sitting right there. They've made it much easier to replace a TXV, but it's still very, very involved to replace an evaporator core. And so if that AC's on and the refrigerant's circulating, that evaporator will become very cold, and then there's a little bit more physics to it. Because it's evaporating, it will pull the heat, the BTUs of heat energy will be pulled from the hot air, and the air will be much cooler, much, much cooler, and that air will then go, let's say to the vents. And so that's kind of a breakdown of AC on versus AC off, and also this temperature door. So if you turn this to cool, that's going to basically pull in cool air, and let's say the AC's off. The best case you're going to get is ambient temperature. So if it's, right now it's pretty warm here, let's say it's 80 outside, yeah, you're going to get maybe 80 would be the best you'll get through these vents. It may be even a little bit warmer because, you may have some heat buildup in the ducting. If you actually want AC operation, like 50 degrees, you'll need to physically turn the AC on, and the AC will have to be functioning correctly to have that evaporation occur in the evaporator core. Now, if there's an AC problem and you're not getting the right pressures, you're probably not getting the right temperatures, in which case the customer complaint will probably be, my AC blows warm. Now, warm to them makes sense, but to a technician, they want to know, well, is it blowing heat or is it blowing ambient? And if it's blowing ambient, that's probably an indication that this is working right here, right? This door is working, but it's not getting really cold because our actual evaporator is not evaporating. It's the AC cycle is not working. Now, maybe that's because we have low refrigerant level. Maybe we've got a problem with the condenser or the fans or the compressor, but you need to immediately determine, are we pursuing an AC problem or are we pursuing a door problem? And so the best advice I can give you is, if you come to the vehicle and they're saying it's blowing warm, go ahead and move the door. If you move the door and it starts blowing hot, 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 and then you move it to cold and it blows much colder, but maybe more like ambient, it's, it sounds like the door is kind of working, and then you're probably looking at an AC system failure. Whereas some vehicles, on rare occasion, it will literally be blowing hot heat. And so if it's 80 degrees outside, 80 degrees ambient, if it's blowing 120, your problem is more related to this door is actually in the position where it's sending air through the heater core, and it shouldn't. So the heater core is hot from engine coolant. So if your engine coolant's 210 degrees, the heater core is going to be close to 210 degrees. You can get some really hot vent temperature. And so if that's the issue, you want to really focus more in on this door, versus if it's ambient, you want to really focus on the AC performance of the system. Hopefully that makes sense. And so while we're on that hot subject, boom, if we go to hot and it's not blowing hot, again, we could move around the door and we could try to determine, hey, is the door seeming like it's working, right? And if there's a good change between hot and cold, but it's just maybe not really getting all that hot, like maybe it's 80 outside, you probably wouldn't have the heat on, so let's say it's 30 outside, and the best you can get out of here is like, 40, 50 degrees, and you move it and it goes down to 30, and you move it to here and it goes up to 50, it sounds like that door is probably working, but maybe the heater core is not getting hot enough. Maybe because of a restriction, maybe because, who knows? Probably coolant flow issues, right? Maybe the thermostat's stuck open, but etc. You kind of want to determine, hey, do I have a temperature door problem, sometimes called a blend door, or do I actually have a heater core problem? So some of those initial steps can kind of give you an idea of which direction this is going to go. Now, we talked a lot about this door. I call it a temperature door, but a lot of manufacturers refer to it as a blend door. It blends warm and cold air. This is a mechanical style. This is very easy to diagnose. The next one we're going to get into, I call the mode door, changes the position of airflow. You'll notice none of that's working, and the reason why, it's an electrical actuator, sometimes called an electric servo motor. So 2 of these wires move a motor, 3 of these wires are a position sensor. And so it's a little bit more complex, but just understanding when you change this mode, it's going to send a voltage to move the motor to the position it wants. And as this little motor moves, it's going to move this cam design, and this cam design is going to close various doors, open various doors. And so if you want it to blow feet, that's some of these vents down here, you'd put it to feet, and this would electronically see its position, electrically run the motor until the position sensor sees what it wants, and then it'll stop the motor, and at which point it should have the vents should be closed off inside by another door, the defrost should be closed off by another door, and all of your air should be coming out the floor. Okay, and then when you go ahead and you change it to defrost or defog, this actuator moves, it runs the motor based on the position sensor, and when it gets to the right position sensor, as indicated by its voltage, that will have these vents closed off and these vents closed off by internal mode doors, and that will leave all the air going this way. And then, of course, you have the mixes, right? So you could have an air mix of, face vents. Actually, this one is defrost and feet. And so the face vents are going to be completely blocked off. Half the air is going to come out the defrost or defog, and half it's going to come out the floor. And that would be another position on here. So this actuator electrically knows each position, and it will go to that position. Now let's talk about that actuator, right? Because this is old school. And it's a good do-it-yourselfer thing, but really I'm trying to educate people who are going to work on modern vehicles. And so you're not going to be diagnosing this a whole lot. This could be a broken cable or a, whatever. It's going to be this, okay? More and more it's going to be electronic, and that's okay. The diagnosis on this could be a little bit more complicated. Maybe there's a self-test. Maybe it sets diagnostic trouble codes. But essentially just a general understanding would be 2 wires go to the motor, and motors go bad. And about 3 wires go to the sensor, and sensors go bad. So you kind of want to be able to diagnose, is it the motor that's bad or is it the sensor? But ultimately, whether it's the motor or the sensor, it's an actuator assembly that gets replaced. And, replacing them varies. That's not really the point of the video, but the point really is, if the temperature door is electronic and the mode door is electronic, and we haven't even talked about the recirculate yet, they're all probably going to be electronic. You need to just understand you could have problems with the actuators. Also, the actuators can fail because the doors get mechanically stuck. And so the way that we would check a door, we would actually unbolt the actuator, or in this case we could pop this cable off. We'd see, hey, how's the door move? And this door seems to move okay. I'd have to fully disconnect it to really test it, but additionally we could have wiring concerns. So this one is a little bit more simplified, but a lot of times these controls actually send a signal to a separate control unit, sometimes called an AC amplifier or a HVAC ECU. That HVAC ECU then sends a signal to the 2 motor wires based on the input from the sensor wires. And so, there's a lot of various different tests, but this is a general overview. A lot of them are going to be electronic. Electronic, and then, we talk a lot about this, but what about this button here, right? Fresh air or recirculate. So if we have it on fresh air, you come over here, you'll notice there's a door in this system, right? This basically is going to seal up against the firewall / wiper cowl. And so you'll notice near the windshield wipers, there's always some grates, some vents, right? And so if we are on fresh air, this is going to open up, and fresh air is going to get drawn in the vents of the cowl. Then if we go on recirculate, this is going to move and close, and then it's going to end up pulling air from underneath. And so depending on what you really want to do, you may want fresh air or you may want recirculate. If you're trying to do max AC, you probably want recirculate. But if you're trying to defog windows because of heavy breathing and unknown said things, you're probably going to want some fresh air coming in because the air inside the cabin is probably very humid from you breathing too much and too rapidly, and it's too warm. And I don't know what you've been doing in there to steam up the windows. We'll just leave it at that. And so that's kind of an overview of we like to call the heater box. And so we'll have to go into way more detail, but this is kind of, what's happening behind the scenes. We'll make one more stop because I do want to point out, the wiper cowl. So I'm going to open the door on a car right now. See there. All right, so check it out. I disassembled a piece here. So here was that recirculate door. So in this position, boom, this would be pulling fresh air. Then in this position, boom, this would be pulling recirculate air. And so all we really need to do is basically move this small hinge down here, and we can do that, typically electronically, right? That's going to be our focus, a lot of electronic stuff. But in the past, we could do it with a cable, or in the past, we could also even do it with vacuum, like a vacuum-controlled servo. And so that's a good view of the recirculate. You can also see now, while they'll put a cabin air filter below here to catch the debris. This is an older one. It doesn't actually have a cabin air filter. And so there's one other very interesting piece I wanted to show you, and it's this heater control valve. They still exist. They're not real common. So this style heater box does not have a temperature door. What it does is it either blocks the flow of coolant or allows the flow of coolant. So if you turned it over there to hot, this valve would open up and it would allow hot coolant in through these lines, and the hot coolant will go into the heater core, and all the air goes through the heater core all the time. So if we have hot coolant go into the heater core, the vehicle is going to blow hot. And if you change it over to cold, this valve will actually close and coolant will not flow, and the heater core will cool down, and you'll have ambient air. And if you turn on the AC, it'll chill the evaporator and you'll actually have cold air. So this is, a heater control valve basically. That is controlled with a door that controls the air. This is controlled with a valve that controls the coolant. Either way can be used to control temperature. Now let's go look at a car. All right, so this is the last part of the lesson. Just a basic overview, but if you look at this cowl, you notice there's all these vents. It's all these basically openings to be able to pull air in. Well, that's where the air inlet is for the recirculate or for the fresh air door. So in the fresh air position, it's going to pull air from here. And then in recirculate, it's going to close it off. So that just gives you, kind of the overall view. And systems vary a lot. This one's a little more modern. And so you can see the control panel's drastically different. This is going to have transistor style blower motor. All these mode, temperature, it's all for sure going to be electronically controlled. And so the concepts are the same. This one actually is a dual zone. So this one would have two temperature doors, one for the driver's side and one for the passenger side. So if the driver's side typically wants it cold, they would put it on cold. And so there's single zone, dual zone, there's all sorts and types of different designs. And then if you're looking for the cabin air filter, you probably find it back in there. Because if you figure that's where the air is coming through for the system, so that's where the filter would be. And so, hope this helps. Just a brief overview. Nothing really super specific, but just for a general understanding.